And this is an arbitrary selection of suggestions to programmers. I have no idea what title we actually used to publish this event, but it's about the same thing. And so what I'd like to do for the next apparently 39 minutes or so is just to share some suggestions for how to be more successful as programmers. Now, everybody defines success differently, so obviously that's why this is an arbitrary selection of suggestions. You can take from them whatever you want and use them however you want, or not use them however you want. This is just one person's opinion. And I have, what I'd like to do is just to talk about a handful of topics, and then afterwards, I will be able to, after the break, we'll be able to handle questions, or if I do a terrible job of managing my time, then I'll talk a little bit longer, and then we'll take questions. Those of you who have something to write with and to write on, and if the thing that you're writing on sticks to walls, then at any point just put something over here in the inbox, and that will give me a chance to sort of have an idea what some questions are before the second half. And if you have no questions, then I guess we'll be out of here quickly. Not all the suggestions that I have are technical, but I know that programmers get nervous when a programmer talks to them about non-programming things. They want something related to code. So let's start there. Those of you who know me, have heard of me, know that I practice test-driven development as my normal way of writing code. I've been doing that now for almost 20 years. And one of the overall things that I've learned about test-driven development in that time has to do with an argument that you might see online about people saying test-driven development is about testing. No, test-driven development is not about testing. It's about design. It's about this. It's about that. I'd like to clear that up a little bit. I practice, the things that I've got from test-driven development over the years have changed. And so there's sort of a meta thing that I want to get out. And that is that when you learn something about a topic, and you change fundamentally the way you think about it, that doesn't mean that everybody else over here who keeps thinking about it the old way immediately become idiots. And yet, if you read articles online, you'll see things like blah, blah, blah considered harmful, even though the thing that they are saying is harmful is the thing that they were doing up until last week. But now, because they've learned how to do things a different way, all of a sudden their old way is considered harmful. No. It just means that you've learned something. Congratulations. And so in test-driven development, you'll hear some people say TDD is not about testing, even though it has the word testing in the name. This is what happens when you let programmers name things. I remember when I first practiced, the reason that I started practicing test-driven development, and back then it was even just test-first programming, was because I had a serious problem. I was terrible at programming. And the way I knew I was terrible at programming was that every day I would make lots of mistakes. You might call them bugs or defects. I like to call them mistakes, because that's what they are. And it seemed like every day, in trying to fix my previous day's mistakes, I would make as many or more mistakes. And you can kind of imagine where that goes, right? Every day, at the end of the day, I would think, finally, I've got this all taken care of. I achieved something today. I did good work. And then I would go home and try to feel good about what I did. And then the next day, bug reports. And so then, okay, fine, I guess I didn't do as good a job yesterday as I thought. I'm going to work at this, I'll fix these problems, everything's great, wonderful, fantastic. Next morning, bug reports. Now, you do this often enough, and if you have any self-awareness at all, you'll start thinking, maybe I'm not as good at this as I thought. And so then I started to get this pain in my chest. Like, you know, it's like being in a nightmare where you're running towards the finish line in a race, but the finish line is running away from you faster than you can run towards it. That was what it was like for me. Every day, I started to think more and more, I'm never going to finish anything, because I'm making more mistakes than I'm solving every day. Finally, at some point, I did the magic thing that makes programmers successful. Well, anybody successful, really, but programmers in particular. I said the magic words, there has to be a better way. The infomercial line, there has to be a better way. And so, because this was 1998, I opened up browser and I went to Alta Vista, which I realize now redirects to Yahoo. And I typed how to test Java code, hit the I feel lucky button or whatever it was called back then, discovered JUnit. That led me to reading books on extreme programming, and all of a sudden I discovered this cool technique where, you know, if you write tests that describe what you're trying to build, then there's a chance you might actually build it. And there's also a chance that once you get to the point where you've built it, you'll stop. Programmers are very bad at stopping, right? We love writing code. Get into a trance, do this, and somehow figure out whether it works. All of a sudden, I noticed that when I wrote the tests first, I wrote less code, and when I made mistakes, I found them sooner. So some people like to talk about defect prevention. To me, the big thing that test-first programming gave me was that it shortened the time between when I made a mistake and when I saw that I made a mistake. And when you shorten that time, the cost of the mistake goes down. I'll come back to that in a little bit. That is to say that when I first started practicing test-driven development, for the first 2 years that I did test-driven development, I wasn't doing test-driven development at all. I was doing test-first programming where my focus was on catching my mistakes sooner, not publishing them to the outside world so that people wouldn't see how terrible a programmer I was. And then a funny thing happened. Without me realizing what was going on, I was no longer drowning in mistakes. And because I was no longer drowning in mistakes, I started to notice something weird about writing tests. And that was that I started to notice that some of the tests that I tried to write were difficult to write. Or even if I figured out how to write them, they were then difficult to understand 3 months later. They were long, complicated, convoluted, and that's when I started to understand the next thing about test-driven development. So when they say test-driven development is not about testing, it's about design. After I was no longer drowning in my own mistakes, now I had the opportunity to look at tests and see that they were giving me feedback about the quality of my design. So instead of drowning in behavior mistakes or correctness mistakes, now I started to realize that I was drowning in design mistakes. And the tests were giving me constant feedback about how terrible a designer I was. So now I was a half-decent programmer who was a terrible designer. And as I practiced and practiced and practiced and got feedback and asked questions, I'll come back to that later, then I started to see that something even more interesting was happening as I practiced test-driven development. As my designs started to get better, which meant that the cost of adding new features didn't go like this over time, but instead went up somewhat steadily and slowly. That's, by the way, the only reason we care about design, right? We don't care because it's elegant, we don't care because it's nice. We care because when we take care of the design, then the cost of adding features stays more or less the same over time. And then I don't have to worry about building the feature now, because in 6 months it'll cost 10 times as much. So I started to notice that not only did my designs start to get better, that adding code 6 months into the project was not much harder than adding code on day one. And that adding code 2 years into a project wasn't that much harder than 6 months in. I also started to notice that I really more deeply understood the things that the books were trying to teach me about design. I remember when I started at IBM trying to read object-oriented design and object-oriented analysis, Code and Jordan. These little tiny books with all kinds of cool examples in languages that nobody used, Smalltalk and Eiffel. And when I read these books, and I tried, I got the same amount of information from these books as I would have got if I just took them and banged myself in the head repeatedly. I couldn't understand what they were trying to tell me until I spent a few years seeing how my design changed, what feedback I was getting from the design when I was writing tests. Learning how to design became a little bit like learning a language. You try to speak a sentence. You look for a confused or an understanding look on the person you're talking to. If you get a confused look, then you ask your friends, how should I have said it? And then you try that next time. And gradually you learn which sentences get an understanding response and which get a confused response, and that's how you learn. And it's good to have a few people who speak the language you're learning and who like you enough that they will teach you how to speak it better. But the way you learn to speak the language is by trying to speak it and getting feedback about how well you are understood. And then you can move on to things like get feedback on how well people respond. And then you're going beyond just competence in the language and getting to things like style and tone and register. I speak to my coworkers differently than I speak to my wife, differently than I speak to the Prime Minister. As you go along, you think more and more and more. And at some point, you are now focusing on style and that kind of thing, maybe even poetry. So the act of writing tests not only helped me improve my design, but it helped me understand the principles of good design. It helped me deeply understand what makes modular design happen, what makes reuse happen, in part because I saw literally tens of thousands of examples of crappy design, slightly less crappy design, crappy design, slightly less crappy design, and then eventually, okay design, pretty good design, good design, really good design. I got to learn that gradually. If I just take, a Hungarian-Swedish dictionary and smack you over the head with it, you're not going to learn Hungarian. But if I put you in a position where you are forced to speak Hungarian every day, you'll learn some Hungarian fairly quickly. Or szeretnék kérni. I would like wine. So that was what really, the progression now was test-driven development's not about, or test-driven development is about testing. I used it to stop drowning in mistakes. And then eventually, no, test-driven development's about design. I'm using it to get feedback about my design so I can stop drowning in design mistakes. To test-driven development is about learning how to design. It's a mechanism by which you can learn and really deeply understand the principles of good, sound, modular design. And then at that point, I don't care whether you organize your code around procedures or objects or functions, it's all the same. So when somebody tells you TDD is not about testing, it's about design, or when they tell you that practice X is about thing Y, on the one hand, I kind of want you to smack them across the face and say, no, that's lazy thinking. I'm happy that you are using technique X to get thing Y, benefit Y. But that doesn't mean that X is about Y. That means that for you right now, the most important thing about X is Y. But that doesn't mean that these poor people over here who have been doing it for only 6 months, compared to you who have been doing it for 6 years, they're still learning the basics, the fundamentals. They're still back at the time where they think that X is about something else. And that's not bad news about them, that's good news about you. Just because you make a big breakthrough in your learning doesn't mean that everything you knew before was a waste of time. It just meant that now you've moved forward. And so if you're thinking about practicing test-driven development, or if you're practicing test-driven development, whatever stage you're in, if you're focusing, let's say, on behavior problems, and you're jealous of all these people who are getting better designs, don't despair. Don't worry. I think it's part of the natural evolution of practice in test-driven development, that at first you do it because you are drowning in mistakes, and then you do it because you're drowning in bad design, and then you're doing it because it's helping you understand more and more how to design well. And then maybe you can even use that as a way to teach it to other people. Trust me, if we could have everyone in this room dedicate their lives to teaching people how to design software well, then I could get on a plane, I could put money in a bank, and not be terrified. And I would love that. So this relates a little bit to risk management. So if you've seen the episode of Seinfeld where George has to apparently do some, I don't remember, it was a presentation at work or something about risk management by accident or somehow. And like, risk management's this weird topic that we don't understand. Let me give you the real basics of risk management in about a minute and a half. So if you read any textbook on risk management, you will learn this. One way to manage risks is, well, first you have to enumerate them. You have to come up with a list of risks. Okay, so then you just sit and think and think and think and talk, and you come up with a list of risks. Right? A risk is a problem that hasn't happened yet, and a problem is a risk that has happened. There, now that's chapter 1. When you identify all the risks, these are the bad things that could happen that would kill your project. Then the next thing they tell you to do is to estimate the likelihood of that risk becoming a problem. So you do that for all your risks. 60%, 40%, 30%, whatever. And then the next thing the textbooks tell you to do is to estimate the cost of the risk becoming a problem. So then you do that. 100,000 kroner, 200,000 kroner, 400,000 kroner, 30,000 kroner. Who cares about that? Blah, 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 blah. Now, I bet you can guess what to do next. If this is the probability of failure and this is the cost of failure, then you calculate what they call exposure. Multiply the probability times the cost, add that all together. What you have here is called your exposure. Before you continue the project, put that much money in the bank. And then you're covered. That's your insurance policy. You need, if this is 1.7 million kroner, then you better have an insurance policy for 1.8 million kroner. Now, there's something kind of neat about this. So this is probably the biggest bit of math we're going to do. Whoops. So exposure is just the sum of the probability of failure times the cost of failure. Nothing complicated here. The symbols might look weird to someone who hasn't been in a math class in a while, but the concept is not difficult. There's a very interesting thing that happens when you start to look at this. So if you want to reduce your exposure, notice that there are two terms that you multiply together. Now, when you have two terms that you multiply together and you want to reduce the product, how do you do that? Well, you either drive one of them down or you drive the other one of them down. And if either one of these could get close to zero, exposure gets close to zero, right? So here's the thing that they don't teach you. Human nature makes you believe that what you need to focus on is reducing the probability of failure. This is what the nice waterfall people do. I want to make sure that I say this very clearly. I am not saying anything bad about waterfall. Waterfall is just agile but slower. Agile is just waterfall but faster. The difference is that when you try to deliver stuff every week, you can't write it all down and figure it all out in advance. Whereas in waterfall, if you're delivering stuff every 3 months, you can fool yourself into believing it's possible to think of it all in the first 3 weeks, argue about it for the next 4 weeks, build it in the next 3 weeks, and then test it kind of at the end. Okay? The waterfall folks, what makes them different from the agile folks is that the waterfall is how they react when something goes wrong. When something goes wrong, the agile folks assume that they need more feedback, whereas the waterfall folks believe that they needed to think about it more. If we had just thought about it longer and harder and better, we wouldn't have made those mistakes. Whereas the agile folks said, well, there's nothing we could have done. At least we found out early, we still have time to fix the problem. Well, we can now take that exact idea and map it here, because the waterfall folks are going to spend all their energy trying to drive down the probability of failure. The agile folks say, you know what's easier? Driving down the cost of failure. Go back to what I said about test-driven development. When I first started practicing, and I was even just doing test-first programming, what happened? The time between when I made a mistake and discovered the mistake got smaller. I used the idea that imagine there's a red flashing light on your laptop that every time you make a mistake, that starts flashing. Hey, idiot, you made a mistake in the last 15 seconds. If you had that red flashing light, how would you program? Well, you would type, the red light would go off, and then you'd go undo. And you'd keep undoing until the red light went off. And then you'd say, oh, I guess I made a mistake somewhere in the last 15 seconds, 30 seconds or so. Let me try that again. Type, red flashing light goes on, undo, until the red flashing light stops. That would be awesome. That's what tests did for me. That's what writing the test first did for me. It gave me that red flashing light. Why did that work? Because it reduced the time between when I made the mistake and when I discovered the mistake. Notice that doesn't say anything about how long it takes me to figure out how to fix the mistake. Merely reducing the time between when I made the mistake and when I found the mistake drives down the cost of the mistake considerably. So it turns out that, for programmers at least, the cost of a mistake is proportional to the time to discover the mistake. And if you're not sure that that's true, think back to your own practice and you can convince yourself pretty easily that that's the case. Certainly the opposite is true. The longer it takes to discover the mistake, the harder it is to fix. Why? Because I don't remember what the hell I was thinking 3 months ago. It's even worse if I have to try to remember what somebody else was thinking 3 months ago. So, practicing test-first programming had the effect of doing this, of reducing the cost of making a mistake rather than the probability of making a mistake. Now, it also happened to, it looks like it's reducing the probability of making a mistake to the outside. I'm making 100 mistakes a day. The difference is you only see one of them. Maybe 0 if I have a good day. What happens when the cost of mistakes gets sufficiently close to 0? Do we even think of them as mistakes anymore? Are they mistakes? Is it a mistake if it doesn't cost you anything? No. At that point, it just becomes an experiment. And experiments have outcomes. What's the subtle shift that happens? I don't know if it happens in Swedish, but it happens in English. What is the subtle shift that happens when you stop calling them mistakes and start calling them experiments or outcomes or results? We stop feeling shame about them. We stop feeling stress about them. We just let them happen. Ooh, another result. It's not the result I wanted, but the good news is I only have to undo the last 15 seconds of work to get something closer to the result I wanted. An amazing thing happens. When you make a mistake, you just hit undo. And you don't even have to try to do any root cause analysis. Just try again. Now, if you make a mistake a second time, maybe it's the same mistake twice, maybe it's a new one. I don't know. Undo. If you make a mistake 3 times in a row, that is when you are too stupid to program. Get up, walk away. Friends don't let friends program while stupid. So if I make 3 mistakes in a minute and a half, that's time to take a break. Get up, start walking towards the door. Probably as soon as you put your hand on the door handle, you'll go, ah! This is the critical point. Keep going. Do not sit down and try to write code again. You're still too stupid to code. You're just a little less stupid than you were a moment ago. Keep walking through the door, go get coffee, go to the washroom, talk to your friends, walk outside. When you come back, the code will still be waiting for you when you come back 10 minutes later. And then you will sit down and you will be less stupid. And you will be more focused and more relaxed and you'll know what to do. So, the only thing you really need to know about risk management is that you don't just don't assume that you have to drive down the probability of failure. If you drive down the cost of failure, then the probability of failure doesn't much matter. And that's why safety mechanisms are perhaps more effective. They're certainly easier to create. Safety mechanisms are easier to create than right thinking. Undo is a hell of a lot more powerful than a better thought process. Now, a better thought process is powerful, but even a better thought process is going to get some stuff wrong. Undo is always going to help you, which is why whenever I sit down to write code, the very first thing I do is try to figure out how am I going to undo the mistake I'm about to make. And if I don't have that, I do that first. There's also a little humility thing that happens in there when you start to assume that you're going to make mistakes, and therefore the first thing you do is build the safety net so that you can make all the mistakes you need to make and they don't cost you anything. So this leads to another thing that, I consider it arrogance to assume that you can just sit down, write code, and it'll be correct, which is why I write tests. There's another kind of arrogance that programmers are prone to. By the way, I'm not excluding myself from this. I have been plenty arrogant in the past, just ask my wife. But another arrogance that I think a lot of programmers, and especially young male programmers, are prone to, is the feeling that it's okay, I can hold everything in my head. I'm young, I'm virile, I'm strong, I'm smart, I can think of 137 things and carry them all in my head. At some point, some of your hair is going to start changing color. I like to say this gray is not decorative. Stress will do it. one of those sources of stress will be trying to remember everything while you're trying to do things. And this is why I'm a fan of, and I promise not to get religious about this, David Allen's Getting Things Done. I'm curious how many people here by show of hands know about getting things done as a way of managing work. All right, for the ones of you who have not put up your hand, I strongly recommend at least doing a little light surfing, trying to figure out something about that. The key message from getting things done as a way of managing work is if you are busy, if you are wasting energy worrying about what you might need to do next, then you are going to find it more difficult to focus on the thing you're doing now. And that's not just some arbitrary thing. That is actually putting stress on you and destroying your energy. And so one of the, in fact, I'm not sure I mentioned it here. I didn't, so let me just very quickly do this. One of the books that I read years ago called The Power of Full Engagement taught me that time management is not nearly as important as energy management. That in fact, stress is a bigger destroyer of productivity than poorly managing your time. So stress is another way of saying poorly managing your energy. Trying to think about the 137 things that you need to do later, you need to do next week, you need to do next month, the values of 37 variables, all that stuff, trying to carry all that in your head while you're trying to write a line of code more or less guarantees that you're going to get that line of code wrong. There's an amazing thing that happens when you can focus on the task you're working on. And until you really experience it, you don't know. I'm telling you, you don't know. It's kind of like by comparison, I am told that when you have a child, you learn a whole new kind of love that you've never experienced before. Now, we don't have children, so I have no idea what that's like. I can only be told what that's like, and I will never know what that's like unless we unexpectedly have children. Please, let's not do that. Similar thing happens if you have never experienced being able to get into the flow state on demand. Then you have no idea how powerful and how productive that makes you. How do you do that? The first step is to get stuff out of your head. So this inbox thing that I drew over here is not just decorative. It is a way that I like to manage all work. Whenever I'm doing any work, one of the first things I do is sit a piece of paper or something down beside me, and I use that as my inbox. What is the inbox? Well, it's just like your email inbox. It's the place you put stuff that you'll deal with later. And as a distraction comes up, an idea, a thought, a worry, oh, I gotta remember to pick up milk on the way home. Oh, shit, if I don't design this well, then it's gonna cost us this much money. Oh, I really gotta talk to the customer about this problem. Oh, I can't forget that we need to build this next week. All those thoughts are robbing you of energy. Write them down. Write them down in the inbox, get them out of your head, get back to what you were doing. And when the current task is complete, then you can look at the inbox, and in there will very probably be the next thing you need to do. And if it isn't, then you figure out how to organize all this stuff. And the rest of the Getting Things Done book helps you understand how to organize that stuff. Now this is also related, in a way, to test-driven development. Not in a way. It is related to test-driven development. If you read Kent Beck's book, the original Test-Driven Development by Example, he talks about a thing called the test list. Once you decide, here is a task I'm now going to work on. I need to build this thing. Before you start building the thing, you first sit down and you write a list of the tests that you think you might need to drive that thing. Now, in Getting Things Done terms, this means that once you sit down to do a piece of work, you probably have some distractions in your head. So, what we just talked about, Michael and I, about if you have to get up and leave, then go ahead and leave, and I won't mind, actually leads me into one of the other things that I wanted to talk about. Let me clear a little space here. What is the least important thing on here? Probably this. Let's get rid of this. So, programmers in particular, let me just grab this in case I need it. Programmers in particular fit a certain stereotype. There's a certain personality type that is common to programmers. Not all programmers have the same personality, but if you're a little bit like me, you were attracted to computers in part because computers did what you told them to do and people didn't. And so computers, now that's, when you're young, that's not so much a statement about power as it is a statement about the machine somehow understands you in a way that people don't. And I think that this is probably, there are probably some of you in the audience who had a similar feeling. And that was one of the things that drew you to computers in the first place. The reason that I bring this up is that programmers, in general, on average, let's say, don't do all that well at the personal interaction, touchy-feely, get along with each other, work together kind of thing. You have an awful lot of programmers who, they like programming because it can be a very solitary experience. It's just you and a problem, and you get to solve it, or not. But at least you get to fight with the computer while you do it. This can be fun for you. Now, I know that growing up, I was a little bit jealous of the kids who seemed to understand how to get along with the other kids. I was especially jealous of the kids who could figure out how to influence what the other kids did. I always wanted to know how to do that. And as I grew up as a programmer, after a few years I started to notice that the technical parts of the job were really not nearly as interesting or as important as the social and psychological aspects of the job. And so one of my most popular tweets, I didn't expect it to be. It was one of the ones that I thought was just kind of a stupid thing to say, but it seemed to resonate, was that, you know, the junior programmer's bookshelf is 90% programming and APIs and programming languages, and the senior programmer's bookshelf is 90% applied psychology. By the way, something like sales is a form of applied psychology. And also trying to influence people's behavior is a kind of applied psychology. And in fact, one of the things that makes, I said earlier that, you know, Agilists are different from waterfall people because waterfall people assume that they can solve problems by thinking more, and Agilists think they can solve problems by getting more feedback. One of the downsides to Agilists is that we all tend to think that we're better psychologists than we really are. I think we know just enough psychology to be dangerous. And if you really want to be dangerous with psychology, because then you can ruin people's lives. It's great.
So are you a salesperson now?
No. I'm a salesperson only to the extent that any self-employed person is a salesperson. I guess, am I a salesperson right now? Maybe, a little bit. Every performer is a salesperson in some way. You're trying to sell the next performance. So I bring all this up to mention that as programmers are not terribly good at the personal interaction parts. You didn't have talent for it when you were young. You didn't have anybody to teach you how to do it. So if you didn't have the talent, you didn't learn. Maybe you got frustrated early, and so you, as I said, you worked with the computer because at least the computer understood you and you understood it. Good news, everyone. I know of a way, I didn't invent it, I know of a way to start going down the path towards actually understanding how people work. And it starts with something called the Sapir interaction model. Now, model is great. Programmers love models because models are descriptions of how things sort of work, right? The old saying is that all models are wrong, some models are useful. The Sapir interaction model, which is named for a family therapist who is a big influence on the grandfather of all software consultants, Gerald Weinberg. If you don't know who Gerald Weinberg is, shame on you. Go find him. Virginia Sapir was a family therapist who contributed a lot to the field of psychology, and especially became known late in her life for applying family therapy to organizational dynamics. One of her contributions is the interaction model. I like to think of this as a way of debugging bad conversations. And that's why it's great for programmers, because programmers love to debug things. If you've ever been involved in a conversation, an interaction that went wrong, horribly wrong, like yelling and screaming and smacking each other and that kind of wrong, then you go into your corner, try to calm down, and then wonder what the hell happened. And the Sapir interaction model gives you a way to figure out what the hell happened, to understand why it went so wrong. And so the Sapir interaction model breaks interactions down into 4 pieces. Let's see if I can remember them all. Intake, meaning, significance, and response. So those are the 4 stages of the model. All interactions go through these 4 stages. Intake. So let's go with I hate you.
I love you.
All right. Interesting response. Intake is literally decoding the signals that came at you. Or sorry, literally receiving the signals that came at you. Somebody speaks, you hear their speech. Somebody writes an email, you read the words. Somebody sits back in their chair, and you notice that they're sitting back in their chair. So intake is literally just receiving the signal. Already at intake, it's possible to have a mistake. So you are having a conversation with somebody, it starts going a little bit off the rails. They keep saying this word over and over again, and then finally you say, "Oh, you're saying which? I thought you were saying something else." So it could be that there's an intake mistake, that you literally just don't receive the signal correctly. It could be that someone's handwriting is so bad that you don't know what word they drew on the whiteboard. Or it could be that their voice is so soft that you didn't really hear what they said. Or their accent is so thick that the sounds didn't make sense to you and you couldn't even figure out where a word began and ended. So these are all intake problems. By the way, you could also have a hearing problem, you could have dyslexia, you could have eyesight problems. There are all kinds of ways that there could be intake problems. And so it's a good idea to first check intake. And so this is related to one of Jerry Weinberg's favorite questions. Whenever somebody says something that makes him surprised, where someone expresses an extreme opinion, I don't like that, this person is trying to sabotage our project. We've worked together now for 6 months. You're that guy who's constantly getting in the way of us trying to improve the way we work. And so I, over coffee, am saying to Jerry, this guy is sabotaging our project. And Jerry will ask, really, what do you see or hear that leads you to conclude that? That's the so-called data question. So that's just one way to check intake. What do you see or hear that leads you to the conclusion you're making? And sometimes you might have an intake problem right away, that you just mishear, misread. Maybe you see something out of the corner of your eye and you react to it right away, and then you realize that in fact what you saw out of the corner of your eye wasn't what you thought you saw. You want to read some fun stuff, read about just how bad our eyes are at taking in visual information. You all have a blind spot right now in your eyes that your brain is compensating for. What? Already, even before we do anything else, we know that we cannot trust our eyes. Eyewitness testimony is not as reliable as we think it is in courts. Great, can't even trust that. And so again, if you have a hearing problem or something like that, then you are at a serious disadvantage. And so you might constantly have to be checking intake. And so you can ask, what did you say? Did you say this? Did you say that? When someone, nice people were indulging me by speaking Swedish to me during the break, I didn't have too much of an intake problem because fortunately they were speaking slowly enough. But when they forget that my ears aren't that good in Swedish yet, they start speaking at normal speed, brr, no chance. And it's even worse if I happen to be doing that in Malmö. I don't have a chance to understand a word. And by the way, it doesn't matter whether they are speaking skånska or danska. At that point, it's the same disadvantage.
It doesn't matter for us either.
Yeah, exactly. That's what I've heard. So one of the first things that you can do is check intake. Here's what I think I heard. Here's what I think I saw. And it's entirely possible that what you thought was somebody sitting back in their chair was in fact not that. So check intake. Now, intake leads to meaning. Meaning is decoding the signal. So in the case of reading, for example, it's understanding the meaning of the individual words and the sentence that they make. And at this point, meaning and significance, many people, I don't know how it is in Swedish. In English, people think these are synonyms. They're not. They do mean two different things, and Virginia in particular used them to mean two very different things. Meaning has to do with decoding the symbols. So, somebody furrows their brow. What does that mean? Well, that often means that they're confused, but it also could mean that they're angry. It could mean that they're tired. There are a whole bunch of things. When somebody sits back in their chair and crosses their arms, it could mean that they're bored. It could mean that they're impatient. Or it could simply mean that this is a comfortable position for them. I'm one of those people who has to remember that when I sit here like this, stand here like this, even though this is comfortable to me, people might decode this as being closed or guarded. And I have to remember not to do that. Of course, this is where there can be a lot of room for error. So whereas with intake you might say mishear or misread someone, in meaning you might misunderstand them. So this happens quite often when you have a heated discussion with somebody in a design meeting or a planning meeting, and they keep saying this thing that doesn't make sense to you, and you keep trying to tell them, no, it's not like that, it's like this, and they insist it's like that. You know that based on having worked with this person for 3 years, you should agree on this. And you don't. You can't figure out why. Until you go back through the meanings of the words that you're using. And I will bet you $1,000 that if you poke hard enough, you will find eventually a word that both of you are using, and one of you means this, and the other one of you means that. And I'm not talking about a slight difference, I'm talking about diametric opposition. I once got into a discussion with somebody who thought that refactoring meant adding features. And I'm not joking about that. That's not a made-up example, that's real. So often, if you have one of these conversations that just goes off the rails and people start yelling at each other, you can almost be sure that one of the causes is that they are using either two completely different words to try to mean the same thing, or the same word to mean two very different things. So that's one of the things that you can look for, is you can look for areas of misunderstanding. One of the simplest ways to do that is, when you notice that this is happening, you can ask, okay, so when you keep saying singleton, I assume you're referring to this design pattern we know where you just create one. And they say, no, I'm talking about like the singleton map, which is a map with just one item in it. Oh, that changes everything. So you can always look for, if you feel confident that you are hearing and reading correctly, then make sure that that person means the same thing that you mean by a word. And by the way, don't ask people, what do you mean by that? That doesn't help. Say to them, so when you say this word, I assume you mean blah, 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 and give them a chance to say, no, that's not what I mean. That's a wonderful trick that I'll come back to in a little bit. Now, after meaning comes significance. Significance has to do with, why do you think they said what they said, wrote what they wrote, did what they did? So whereas this is about decoding the signal, this is about inferring intent. This is about asking why it is that somebody would want to project confusion at you. I mean, it's one thing to sort of react and be confused. It's another thing to go out of your way to try to show someone that you're confused. Maybe because they've been talking too long and they're full of shit, and you want to show them just how crazy they are by staring at them. Or, again, go back to, I hate you. Now, the meaning of I hate you is fairly clear. I think we can all agree on what the words I hate you mean in the English language. But what's the significance of that? Am I joking? And I have particularly deadpan humor. Am I using this as an artificial way to prove a point, like I might be doing in a context such as this? Or have I been waiting for 10 years to tell this guy and try to embarrass him in public by telling him that I hate him? You don't necessarily know. But think about all the things that go into deciding the significance of someone's behavior. Now, the thing about significance is that this goes very deep. Significance has to do with, so this is now, you might misinterpret someone. And the word interpret is really important here. Significance is all about interpreting someone's words, deeds, behavior, however you want to. I'll say behavior as the general word. You are making a guess about what they are, what their motives are in behaving a certain way. And anytime you make a guess, you might be wrong. Think about all the things that go into the significance that you attach to behavior. The way you were brought up by your parents, the country that you live in, the language that you speak, all the incidents of your childhood, adulthood, of your whole life. Significance is deep. It's way, way, way in here and way, way, way in here. You don't have a lot of control over the way you interpret the world. You learned a lot of it before you had any authority on the matter. You were taught stuff as a kid. This is what leads towards one of Jerry Weinberg's techniques about transforming rules into guides. We limit our own behavior because of weird beliefs that we probably picked up as kids. Jerry calls them survival rules because we follow these rules in order to survive in the world. One of my survival rules is you don't go where you're not invited. I can remember as a kid being told by a respected authority figure, don't go where you're not invited. He thought he was giving me grandfatherly advice. He didn't realize that he was crippling me for life. Because don't go where you're not invited is really bad advice for an entrepreneur. Really bad advice for a self-employed person who needs to promote themselves. So then there I am at my first conference, afraid to talk to people because I didn't know anybody and they didn't know me, so nobody invited me to be part of their discussions. So then I would stand there. That's boring, isn't it? So that is to say that the way that we interpret the world, so by the way then, when I see somebody else going where they're not invited, I think, oh, what an asshole. How arrogant. And then, of course, there's a little bit of, gee, I wish I could do that. So this stuff is deep. And because this is deep, significance leads to response. So your response was rather happily non-complimentary, meeting hate with love. Wonderful. It could just as easily have been a punch in the face. The path from significance to response, well, you choose how to respond based on how you interpret a situation. No, you don't. One of the consequences of the fact that significance is deep in here and deep in here means this is the cruel truth about this model, and that is that the path from significance to response is lizard brain stuff. It is almost always involuntary. So one of the basic rules that you can use from the Sapir interaction model is always assume that a person's response follows logically from how they interpreted what has happened. When they attach significance to what's going on in your interaction, their response is always logical. So this is sort of like a prime directive of talking to people. you can assume that if somebody responds in a way that seems strange, the cause of that is that they've interpreted the situation differently from what you expect. But that if you understood how they interpreted the situation, you could see yourself responding the same way. So if you genuinely thought that I hated you, it would make total sense for you to smack me in the face. And if I realized that for some odd reason you actually thought I hated you, well, shit, I would smack myself in the face too. So for me, the prime directive of interacting with people is this idea that the path from significance to response, you can assume that it's both logical and involuntary. Now, when I mean logical, I don't mean rational, I mean follows logically. If you interpreted the situation the same way they did, you'd probably respond the same way. Which means that if somebody starts reacting to you in a way that you don't understand, you should assume that they are interpreting the situation differently than you expect. So then you start checking. First, check intake. Okay, so you know I'm saying the word witch, right? And if they say, yeah, I understand you. Well, you know when I say witch, I literally mean like the mythical character, not the word that means a particularly unpleasant woman. I actually mean like, witch, broom, wings, the whole thing, Halloween, that kind of stuff. Once you figure out that understanding is okay, then ask, well, you know that I'm talking about witches because we have this weird Halloween promotion coming up. That's all I'm trying to do, is I'm trying to deal with the fact, I'm trying to get through this stupid discussion about this Halloween promotion because I'm so sick of dealing with this kind of crap. This promotion drives me nuts every year. We never do it well. It always goes poorly. Let's just get this over with. That's why I'm talking about it now. I know this is a ridiculously contrived example, but the whole point is once somebody responds in a way that doesn't make sense to you, first check the intake. What did I see or hear? Then check meaning. When you said this, did you mean that? No, I meant something else. Ah, okay. And if the meaning seems to fit, then you can assume that there's something about the way the person interprets the world that is different from what you expect. And so when somebody responds strangely, you should never tell them to change their response. You should always ask them to at least change their interpretation. In other words, don't tell them that's not how to act. It's, you know that I wasn't actually trying, like, I was just sitting back like this because it's comfortable. I'm paying attention. So you know the whole thing, that there are some people who, if you talk to them, in order to listen to you intently, they end up looking away. They're not doing that because they don't want to make eye contact. They're doing that because it's a loud, they might be doing it because it's a loud room and this is a better way for them to hear you. You might interpret looking away as not being interested in the conversation, when what's really happening is the exact opposite. I'm trying harder to hear you and this is the way I do it. So if you see someone reacting strangely, check intake, check meaning, check significance. Assume that this is the problem. And so if you can figure out how they are interpreting the world, then their response will make a hell of a lot more sense. The last thing I want to say about this is the cruel irony of the Sapir interaction model is this. Their response leads to your intake. Because when they smack you across the face, you intake the impact on your cheek of their hand. And then you attach meaning, significance, and response, and your response goes to their intake. This is our good friend, the feedback loop. And a positive feedback loop is a feedback loop that amplifies. And that is how we go from having a nice discussion about software design to wanting to kill each other in 3 easy minutes. So, how do you use this? Stage 1. You have a conversation, it goes horribly wrong, you scream, you yell, you extract yourself from the situation, you go, you sit, you calm down, and then you use this to help debug the situation. And you ask, okay, is there something that I might have seen that wasn't really there? Is there something I might have heard that I heard wrong? Check to just replay the tape in your head. Okay, what did I see or hear that led me to get upset? No, I'm pretty sure I heard that all right. Okay, I'll check that later. Meaning, are there any words that, now that you think of it, they might have been using the same word to mean something else? Were there any unclear words that you used? Were there any ways that maybe somebody could have misunderstood what you were saying? And then look for significance. Is there anything that I was doing that, I didn't think was a big deal, but somebody else might think is a big deal? I can remember being on a conference call with a client, and I'm calmly asking questions. And I found out later from my colleague, who was also on the call, that the client thought that I was passive-aggressively challenging everything they said. I thought I was rather neutrally and calmly asking important questions. Interpretations are weird, man. And so I was constantly asking questions and going quickly because I only had 20 minutes and had to get off the call. They thought I was being belligerent, arrogant, rude. So, first, go use this as a way to debug the conversation. That's stage one. Stage two is, while you're having the conversation and you notice that it's starting to go off the rails, start asking questions. Check meaning, check significance. Those are the two most likely problems. If you know that the other person has intake problems, try to be sensitive to that. If you know their hearing isn't very good, or their eyesight isn't very good, or if you know it's a loud room, that's a situation where intake could be the problem. So that's stage two. In the middle of the conversation, you can be asking things like, okay, you know that when I use this word, I mean this and not that, right? Or you know that when I'm sitting back, I'm not actually upset. This is my way of being comfortable. Or you might have to say, you know what, I don't think I'm saying anything that should make you this upset right now. What am I saying right now that's pissing you off? And then you can be checking meaning and significance at the same time. And then they say, well, it's not so much what you're saying, it's how you're saying. Oh, I'm sorry. Honest, I raised my voice because it got noisy in here. I'm not yelling at you because I'm angry. I'm yelling at you because I'm not sure you can hear me. When you have interactions with somebody who doesn't hear well, you have to be very careful, because raising your voice could be a way of making sure they hear you, but it also sounds a lot like yelling. So this can be a common source of problem. So that's stage two. As it's going on, check in. Check to see each of these. Stage three is kind of the annoying stage. In the annoying stage, you are trying very hard to prevent these problems in the first place, which then leads to the rather annoying situation of trying to have the conversation about the conversation instead of having the conversation. And so eventually you get to the point where you start saying, so if you know that you and another person are sort of at this stage where you're both using this and you're both trying to, I want to anticipate ways that you might misinterpret what I'm about to say, so I want to sort of preface what I'm saying with a way that clarifies my interpretation. And eventually you start saying things like, okay, can we please just have the conversation instead of having the conversation about the conversation? This is driving me nuts. And then by stage four, you sort of do this stuff more naturally. You start to develop an intuition for when it's a meaning problem or a significance problem. And I promise you can get to stage four in like 10, 12 years of practice should be enough. That's how long it took me. The good news is that once I learned about this model, I could start using it to debug conversations after the fact right away. And it really started to help. So, strongly recommend this. This is a good way to start figuring out how the hell people work. So at least being able to understand when a conversation goes wrong, or an interaction goes wrong, what the hell happened.